Hello students, good morning. So we are going to discuss here the chapter Electrostatics. Electrostatics is a chapter where we actually considering the charge, the static charges. Static in the sense, so we are not considering their movements. So when suppose there are two charges, Q1 and Q2, which are kept static at a distance r from each other, then, according to the first, according to we know that the like charges repel each other and opposite charges are attracting each other. So, from this notion, the very notion of that, we can easily say that this the force one charge is exerting a force on another, right? So, when a charge is exerting force on another, so now we have to know how the force is and how what is the nature of the force. This force is given by the Coulomb's law. Okay, what does it say? It is saying that a force on a charge Q2 uh, by Q1 is given by this formula. So the force exerted on the Q2 is given by this formula F K Q1 Q2 by R square. So it is called the electrostatic force. But force is a vector quantity. So we have to keep the vector sign. And to give the vector sign, we have to remember that any vector can be represented by its magnitude into unit vector. So if the unit vector is r cap, okay, along the r vector, then the force, the vector form of this law is given by q1, q2 by r square into r cap. But we have to remember to write down this law, we have already assumed something. The assumption is the origin is chosen at the point of Q1. Okay, if the origin is chosen elsewhere, the structure of the formula of the law will be same, but the structure will be slightly different. Okay, we'll be discussing later. But right now, it is sufficient to take the origin at Q1 and find the force and to know the force that is K Q1 Q2 by R square. Students, you know that from the gravitational chapter, the gravitational physics, what we have already learned in class 11, we have already seen this kind of force. This is almost a similar structured force, right? So you have studied that when the two masses, okay, instead of charges, we are considering, hmm, so M1 and M2, and they are kept at a distance, they are kept static at a distance r. Then the force between them, the gravitational force between them, G M1 M2 by R square, right? Good. So it is almost looking like the same. These two forces are looking like same, right? But we have to remember a very important differences between the two forces. And that will actually help us to build the concept in our mind what the electrostatic force is. Okay. So, in these two expression, one is for the gravitational force and one is for the electrostatic force. You can already see that one by that both forces are proportional to 1 by r square. Okay. So this particular behavior has a name in physics. So this is called inverse square law. Okay. So another important and very actually not only important, very important difference between the two forces is the proportionality constants. So in the electrostatic force, the proportionality constant is K, right? But in the gravitational force, the proportionality constant is G. And G is called the universal gravitational constant. And the K is simply known as Coulomb constant. Okay. So what is the difference between these two constants? So you can already you have already seen that there is a word before the name of gravitational constant. It is called the universal. What does it mean? The universality of this law, this gravitational force is actually carries the universality. What does it mean? That means if I keep the two masses, M1 and M2, anywhere in the universe, provided the distance between them is same, then the force will be remain same. That means the G is not changing with with G does not depend on its position in the medium between the two masses. For example, if I take the two masses inside water, keeping the distance between them, keeping the distance between them same, the G remains same. And if the G remains same, that means the force remains same. That is a still it is G m1 m2 by r square, even they are kept in water. So D does not depend on the medium between the two masses, right? So G does not depend on the medium between the two masses. This is the main feature what the G carries, capital G carries. Okay? But here the K is actually acts totally opposite to the characteristics of G. So what is the characteristics of the Coulomb constant? The Coulomb constant is actually the Coulomb constant is actually telling that when the two charges is kept in any other medium, in any medium we can take. So suppose the Q1 and Q2, the two charges are kept in their different medium, okay? Different medium, then different in the sense it is different from the vacuum or air. Suppose in between there is water, then the force will be different. That means the K actually depends on medium. Okay. So the big difference between the capital G, that the gravitational constant, and the Coulomb constant is the Coulomb constant depends on the medium between the charges, where the capital G does not depend on the medium between the masses. So that is a big difference. Okay. Generally, in air or vacuum, okay, so the K is 1 by 4 pi F, it is written as 1 by 4 pi epsilon naught. What is the epsilon naught? Epsilon naught is the permittivity, it is known as permittivity of vacuum or air. Okay. So what is the physical significance of the permittivity? Permittivity is telling if a medium has the permittivity, that means it can it can actually sustain the electric field or sustain the electric force between the two charges. It can hold the electric force, or the electric force is defined, can be defined in this medium. Without the permittivity, we cannot bring the electric force or electrostatic force between the two charges. So it gives the what is the physical significance? So physical significance is that it actually gives the existence of electrostatic force between the two charges, between the two static charges, okay? Because we are dealing with just electrostatics. Yeah. Okay. So generally, the value of the epsilon naught, we do not have to remember that. So because it is already given in the board exam, and the K value actually the well known nowadays. So the value of the K approximately equal to 9 into 10 to the power 9 in SI unit system. Okay. And we are going to find the what is the units, the right units of the Coulomb constant in a unit system later. But right now it is sufficient to know that the K, the Coulomb constant actually depends on the medium between the two charges. Okay. And that is our beginning part. So in summary, we know now the force between the two charges, that is Q1 and Q2. And if the origin is chosen as Q1, the force between the distance between the two charges is R, then the force between the two charges is given simple by K Q1 Q2 by R square into R time. That is the vector set. Okay. And K depends on the medium, hence the force does so. That means the force also depends on the medium between the two charges. So now we are going to see that how the force varies with the different medium. Okay. So suppose in air the force is between the two charges is given by this formula. So and when the two charges is kept into water, that is Kw. So this Coulomb constant is changed to Kw, which is representing the Coulomb constant in water. So it's the force becomes Q1 Q2 by R square to R2. So now, and I'm just going to designate the force as Fw, which is the force between the two charges in water. Okay. So now we are going to take the compare the magnitude of the two forces, and to get the comparison, we take the ratio of their magnitude. So Fw by F, we are going to consider. So students can easily notice that Q1 Q2 by R square, Q1 Q2 R square, both are same in the two expressions. But only the difference they have is the Kw and K. So the ratio actually, all this the Q1, Q2 R square will be cancelled out from denominator and numerator, and Kw by K. Okay. And again, we have already known right now that K is given by 4 pi epsilon naught. Epsilon naught is the permittivity of the vacuum. Uh, and Kw, similarly, we can write it is 4 pi epsilon W, right? Epsilon W is the permittivity of water. So if I put the explicit expression of the K and Kw in here, we can see it is actually giving me the opposite ratio of the permittivity, right? If I put that, it is easily to find that. So this is, it becomes epsilon naught by epsilon W. The ratio, now we have to know another definition, a very important definition in electrostatics, and it is often asked in various competitive exams to calculate the force in a different medium. That is permittivity of any medium by permittivity of air or vacuum is called dielectric constant of the medium. Okay. So it is often written with designated as with capital K. So if I now put so permittivity of the water, if I apply the same thing epsilon W by epsilon naught, it is Kw, and it is easy to see from this expression that it is opposite to, it is a reciprocal of the Kw, right? So we can write it is by Kw. So the ratio of the two forces, the magnitude of the two forces becomes Fw by F equal to 1 by Kw. That means the Fw equal to F by Kw. Right? So this is the final expression of the force between the two charges when the two charges are kept in water having the same distance. So generally, and we will actually study why it will be. But right now, you have to remember that the dielectric constant of any medium is greater than 1. That means the force, the force between the two charges, which is kept in the water, that is the F. So we have to remember the Kw is always greater than 1. Here, that is Fw by F, that is equal to 1 by Kw. And Kw, since the Kw is greater than 1, we can easily see, okay, So we can easily see that is F is greater than FW. What does it mean? It means that the force between the two charges in vacuum is always greater than the force between them in any medium. And if I know the force somehow, that is the if I know the force between the two charges, somehow in air or vacuum, we can easily find the force in any other medium if the dielectric constant is provided. It will be F by K. So the summary is the force. If I know the force between the two charges in vacuum, then the force between the two charges in any medium is given by F by K, where the K is the dielectric constant in that medium.